Hi there, welcome again to our science review, and this time we're going to discuss what mixture is. So remember that matter is divided into two groups. They are pure substances or a mixture. And therefore, pure substances that we already discussed, yes, they are divided into elements, where they are elements or a compound. And what about when it comes to mixture? How are we going to differentiate a pure substance from a mixture? And what are those examples of mixtures? Let us analyze. So let's begin with identifying these pictures, whether it is an example of an element, a compound, or a mixture. Definitely, you will see that the middle picture represents an element because the atoms are the same. No other substance or let's say element is bonded with this element. So yes, definitely it's an element. And look at this picture, the right side of this element. Therefore, some or let's say another elements are bonded with this another element, and you will see that they are really attached. And somehow we can say that this picture is an example of a compound. A compound is a combination, it's still a pure substance, but it is a combination of two or more elements to form a molecule. Let's say that the green round thing here or particle is a representation of oxygen. So we have one atom of oxygen and two atoms of hydrogen, making it a molecule or a compound, and that is H2O, or what we know as water. So just an example. And look at this picture at the left side. You see that it composed of different substances and they are mixed in one container, but still you will recognize each of them based on their color, right? You can easily recognize them. That what makes it a mixture. So let us now begin determining this mixture, identifying and even examples of this mixture that I see. Mixtures are composed of two or more substances that are mixed together physically. Remember, it is being mixed physically. Whether you stir it, you, uh, whatever kind of physical mixing you do to the mixture, again, they are combined in any proportion. So, no definite proportion for a mixture, unlike a compound. So, once you mix those substances together, there will be no chemical reactions that will occur. Unlike compound, once the elements are bonded together, they will form a new compound. So, properties of each of those elements will be lost and form another property. Like this, when you like to eat broccoli, you can still recognize where are the broccolis are, and components can also be separated physically. You mix them physically, you may also separate them physically. The two categories of mixtures are homogeneous and heterogeneous. Homogeneous are uniform mixture, meaning to say they have the same proportion of the components all throughout the mixture, and you may assume a single phase, like looking at the following examples. When you mix them together, water in this particular, once you mix them, you can only see liquid and color yellow. Am I right? Even vinegar, you think it's water, but when you taste it, it's sour, meaning to say there's another substance being mixed here. They are uniform all throughout. Even sauces, fish sauce, coffee, or even tea. This homogeneous may form a solution. Solution is usually clear and transparent mixture. Like when you mix this powdered juice in water, you will only see a transparent nature and it is clear. And therefore, particles are atomic scale in size. They are so small and they are scattered all throughout. Even you look at it, you're not going to notice that there are some powdered juice mixed here in water. Sea or salt water is also an example of a solution for the reason that seawater, wherein the particles of the dissolved material are separate molecules or ions, and they are or they cannot be seen under the microscope or compound microscope. Particles are spread through all throughout, and they can or will never rise to the surface nor sink to the bottom of the water. So the dissolved materials cannot be removed by filtration because you mix them thoroughly, like mixing salt to the water. You see, you will never notice that there is salt in water. They are dissolved thoroughly. Another example of a mixture is heterogeneous. So, mixture is not uniformly mixed, and components are still distinguishable, can be separated through physical means, like my examples here. You can still recognize each of those components mixed together, and you can separate them physically. Suspension is an example of heterogeneous because some particles settled at the bottom of the container, and particles are not evenly distributed. Like here in my picture, when you mix sand and water, after a few minutes they will settle or sand will settle at the bottom of the container. That is why they are called suspension. Another example showing you suspension. Even the blood, after a few minutes, red blood cells will settle at the bottom of the container because this one is denser than the other components of blood. Soil and water will do the same. The second example of heterogeneous is a colloid. The particles of colloids are bigger than solution, but smaller than those in suspension. They are not distributed uniformly, and particles may settle down slowly, like milk. As you can see, particles are bigger than suspension, and you can even test it using the Tyndall effect, which later be discussed. Now, these are my examples of colloid, like the whipped cream, honey, shampoo, jellies, and even ketchup are called colloid. You may see only um, one property, but still they are colloid. So let us now have this comparison among solution, suspension, and colloid. How are we going to distinguish them? So remember, the particles of solution is somewhat smaller than suspension and colloid. And based on the size, next to solution are the colloid, and then finally suspension. The reason why they settle at the bottom of the container, the suspension, because of their particle size. Table salt dissolved in water is a form of solution. And if you are going to, based on their appearance, if you are going to compare that in a suspension, let's say a flour being mixed in water, after a few minutes, the flour will settle at the bottom of the container. And in milk, it is an, an example of emulsion. It's a colloid, and the particles are somewhat bigger than the particles of solution. They will slowly settle at the bottom of the container, but not the same way as suspension based on the size of their components. So we may also use the Tyndall effect or the scattering of light to for you to determine which one is a true solution and which one is a colloid. Since suspension, it is easier for us to distinguish it from the two. So when the light being seen in a substance, then it is an example of colloid. The thickness of the particles of colloid makes this light visible like fog during a foggy day. Even you are using the headlight, you will never see, or it will be hard for you to see the road. Same with this, using the light, what, or using light, getting the effect of light to see where which one is colored and which one is solution. So solution is clear in nature, colloid is not. If you see particles settled at the bottom of the container, it's a suspension. So I hope you learned something from what we reviewed this day. It's all about mixture, and mixture is different from what we know as pure substance. So thank you very much. I hope to see you again on our next review. Bye bye.